For example, some 4G telecommunication broadcasting towers are more than 1,900 feet in height, which is taller than the Empire State Building.
According to OSHA's top administrator, the people who climb these extremely tall towers for jobs have the most dangerous job in America. They have 10 times the fatality rate of the construction industry.
We created a prototype system for robots working in the communication towers. Robots will reduce the risk of dying and lower the cost of insurance for tower administrative companies.
We are using 2 LEGO NXT 2.0 bricks and 1 LEGO EV3 brick set. Our robots' names are Jake the Field Crew, Randy the Controller, and Bob the Climber. Now we'll give you a live demonstration.
Randy the Controller scans the light using a color sensor, which is pivoting on an axle in clockwise and counterclockwise directions. When a light goes out in the tower, the same colored light goes out at the control center, which is then scanned by the color sensor. It will then stop pivoting, and then the other motor will move accordingly to press the corresponding button on the IR remote to send an IR signal to Jake the Field Crew. It will also move the bottom gear to make an electrical connection at the right warehouse. We ask you to choose one light we would switch off, so you can choose one, blue or red one. Blue. So scan and pivot. We'll scan and send an IR signal to Jake the Field Crew.
Jake the Field Crew receives the IR signal and ignores the red one because it is the blue one part that he has to get. He turns to the blue warehouse, picks the parts up in it,
We have attached a very special feature on Bob the Climber. We have attached a pendulum on him. Behind that is a color sensor. If Bob is slanted, orange or black will appear in front of the color sensor. Both colors mean something. It means that one motor will stop and one motor will keep on going for Bob to regain balance. We have attached this feature because if you are going to cut against gravity, then you must have balance.
My name is Jean-Marc Campbell and I am the Jomo Soko team. I have created and programmed the sortinator. The objective of the robot is to sort and count the colors on the envelopes. In designing the robot, I had several problems, such as making a strong structure that can hold at least 20 envelopes. Another one was only distributing one envelope at a time. I solved these by implementing a turning table and 2 side barriers. The first version of my program was very slow and inefficient. I enhanced it by programming it to detect the color and then detect the quickest way to go from its current position to the position the color should be placed in. Now, this caused my program to become extremely large. Then I had to use variables. This also enabled me to allow the user to be able to set up the robot. And now for the demonstration. It moves to the center position and reads the first color. It then detects, dispenses the envelope and determines the shortest, reads the next color and determines the shortest route from its current position to the next position. While this is happening, it updates the counts and percentages on the remote. Counts. Okay. Percentages. Using this program but with different sensors or scanners, the robot can be adapted for many other uses.
Hello, my name is Krishna Govinan. I'm Darren Tisillo.
And I'm Jonathan Mee.
perfect idea to map out the surface characteristics of various terrestrial planets, but I can't because I don't have any of the right equipment.
Well, you ran to the perfect people at the perfect time. We are currently building 2 interplanetary rovers. The way these rovers work is you send them to another planet and they will drive around fully autonomously and with remote control, and they will read back sensor data information.
So, how do you navigate these rovers?
So we have an autonomous and a manual rover. The autonomous rover works with 2 ultrasonic sensors and 2 motors. So each ultrasonic sensor represents the opposite motor. So the logic behind it is, if it is greater than 30 centimeters, it will go full speed forward. If it's less than 30 centimeters but greater than 8, it will turn away from the object. But if it's less than 8, it will do a pre-program. It'll sense the object, it'll back up and turn around to avoid any objects that may suddenly occur. This is the manual over here, which is controlled by the remote. So each lever here represents a motor. The farther forward you turn it, the faster it will go. We also have a button here for the pH and moisture detector. When you hit it, it goes up and down. There's also a brake button here, which overrides any commands, as you can see here.
So, I see you have a variety of sensors. How do you collect and represent their data?
So, all the sensors are connected to the Adreno. The Adreno is then connected to the USB extender. The USB extender, along with the camera, are both connected to the mission control strings over Wi-Fi, which was provided by our router. And then all the sensors have a transfer function. The way this works is you have to create a function of counts and the actual readings. So, for example, for our thermometer, our thermistor, we had to take actual count readings, and then we had to take 3 actual count readings, then we had to take 3 Celsius readings. Then we would take them, put them into a function, calculate them, and then you get those numbers, you put them into the code through the mission control, which is provided by the Adreno, and then it will show up as Celsius readings, as you can see here.
So, can I see a sensor demonstration?
Sure. Now, take it away. Now, for the light detector, this USB light can be pointed at this light detector, and then light has gone up. And then for the radiation, right here, you can put it here, and then the ionization chamber will detect it, and the radiation detector will be affected through the compass. And then for the metal, in the case of the metal detector, here, put metal under it, and then the metal will shoot up from there. And then for heat, the thermometer right here. If I put my hand on it, it will go up.
And that concludes our presentation.